The concept of panspermia suggests that life can travel naturally through space, much like seeds being dispersed across the universe. This idea has been debated for a long time, but recent discoveries and research have given it new credibility. In the past, scientists believed it was impossible for living organisms to survive the journey through space, from being ejected from one planet, traveling vast distances, and landing on another. However, studies have shown that microorganisms may indeed be capable of enduring such extreme conditions. Interest in panspermia was reignited in the 1970s when researchers discovered Martian meteorites on Earth, proving that materials could travel between planets in our solar system. Scientists then explored different ways in which biological material could survive these journeys, and their experiments demonstrated that spores and microbes could endure harsh space conditions, both individually and in combination. Experiments suggest that microbes could potentially survive the trip from Mars to Earth or even between other habitable planets. But it doesn't stop there. Several moons of Jupiter and Saturn, such as Europa, Ganymede, Callisto, Titan, and Enceladus, may also be viable locations for microbial exchange. Some microbes have even been shown to survive in space for years with minimal UV protection, and if shielded by a thick layer of rock, they could persist for millions of years. Perhaps even more astonishing, scientists have revived microbes on Earth that were dormant for 250 million years, similar to finding a fossil that suddenly comes back to life. These groundbreaking discoveries have transformed our understanding of life's resilience and expanded the scope of astrobiology, the study of the origins, evolution, and distribution of life across the universe. Mars remains one of the most promising locations to search for extraterrestrial life. Evidence suggests that it once had Earth-like conditions, and traces of methane in its atmosphere could indicate biological activity. Additionally, the discovery of subsurface liquid water lakes on Mars raises the possibility of microbial life thriving beneath its surface. Europa is another fascinating candidate, with its vast subsurface ocean potentially hosting life in a manner similar to deep-sea hydrothermal vents on Earth. Likewise, Enceladus has hydrothermal activity on its ocean floor, releasing plumes of water vapor and organic-rich particles, further evidence that extraterrestrial life may exist in our solar system. While panspermia is one potential explanation for the spread of life, other theories also attempt to unravel this mystery. One such idea is directed panspermia, which suggests that life on Earth may have been deliberately seeded by an advanced extraterrestrial civilization. While this theory is speculative, some scientists consider it a possibility, arguing that life on Earth may be too complex to have formed entirely by chance. Another theory, known as chemical evolution, proposes that life originated from simple organic molecules that formed spontaneously in Earth's early atmosphere or even in space. These molecules gradually combined and evolved into more complex structures, eventually leading to the emergence of living organisms. A landmark experiment supporting this theory was the Miller-Urey experiment in 1952, which demonstrated that amino acids, the building blocks of life, could be produced from simple inorganic compounds under conditions similar to early Earth. Another intriguing idea is the hydrothermal vent theory, which posits that life may have originated deep in Earth's oceans near hydrothermal vents. These vents provide a rich mix of chemicals and minerals in a heated environment, creating conditions suitable for the formation of organic molecules and the evolution of early life forms. Some scientists believe that the first microorganisms thrived around these vents, eventually spreading to other parts of the ocean and beyond. The RNA world hypothesis suggests that RNA, ribonucleic acid, was the first self-replicating molecule, paving the way for life's evolution. RNA is unique in that it can both store genetic information and catalyze chemical reactions, making it a strong candidate as a precursor to DNA and proteins. According to this theory, early Earth was rich in chemical compounds that, over time, combined to form RNA, which then evolved into more complex life forms. Ultimately, the origins of life remain one of the greatest scientific mysteries, and new discoveries continue to challenge and refine our understanding. As our exploration of space advances, we may one day uncover definitive evidence of life beyond Earth. If you found this exploration fascinating, Be sure to like and share this video. For more thought-provoking content, check out our other videos and stay tuned to Factonic.